What's up? I'm Vin, and I'm going to solve equations that involve rational exponents. So for this first equation here, what we could do is first mention which x values are not allowed. That way, at the end, when we get our solutions, we know if we have to reject anything. So just looking at this expression on the left, I could see that if x is equal to 0, we would have our equation undefined here because we would have division by 0. So x cannot be 0 for this first equation here. So we could start off here. We have 1 over x to the third plus 4 over x squared. And this expression I'm going to multiply by x over x because I want to have a common denominator with x to the third. And then we have plus 4 over x. And that final fraction I'm going to multiply by x squared over x squared. And this whole thing is equal to 0. So from here, what we have is we have 1 over x to the third plus we have 4x when we multiply over x to the third. And then we have 4x squared over x to the third. So now on the left side, we have all of our fractions with common denominators. So we can combine everything into a single fraction like this. Okay, so this is fine. We could just go ahead and write everything as a single fraction because we have 3 fractions with common denominators. And this is all equal to 0. So from this step, let's just think about this. We have a fraction equal to 0. So a fraction is equal to 0 when the numerator is equal to 0 and the denominator is non-zero. So anytime you have a fraction equal to 0, this would mean that a is equal to 0 and b is not equal to 0. Okay, so this is just an extra condition here. The denominator cannot be 0. So from here, we could just set the highlighted stuff equal to 0 using that idea and solve the resulting equation. So from here, what I'm going to do is I'm going to use the AC method. So in general, when we have a quadratic, we have the a term is the coefficient of x squared, the b term is the coefficient of x, and c is the constant at the end. So I want to look at the product here. This is what I'm thinking about. I'm looking at the product of the a and the c term, which is the first and last term. Not to be confused with these a and b values. This was just for fractions in general. But we have a times c is equal to 4, and the b value, the term before x, is 4. So I'm looking for two numbers that have a sum equal to 4, and the numbers also have to have a product equal to 4. So the numbers that would work here would be 2 and 2. So I'm going to rewrite this as 4x squared plus 2x plus 2x plus 1 equals 0. You might just be able to look at that and say 2x plus 1 squared, but let's say that wasn't obvious, then you could use the AC method, which I'm using right now. So now we take out a 2x, and we're left with 2x plus 1. And then I'm going to write plus 1 times 2x plus 1, because now when we factor, we're going to have 2x plus 1 times the leftover 2x plus 1 is equal to 0. And I could write this if I want as 2x plus 1 squared, but either way here, we have enough information to get to our answer. So I just have to set one of the factors, 2x plus 1 equal to 0, because if I set both equal to 0, I'm just going to write the same answer twice, which I would only have to write it once at the end anyway. So these terms cancel when we do 1 minus 1, and now we have 2x equals negative 1. We divide both sides by 2, and this tells us that x is equal to negative 1/2. Question 2, we're solving this equation for all real values x, and one thing we have to know is that a to the b over c is equal to the c root of a to the b power. Just know that the numerator is the power, the denominator is the root. We have power over root. And the next thing we should know is that a to the b to the c power is equal to a to the b times c. So we could start solving this equation by squaring both sides. So we have x squared times the square root of x plus 3 is equal to, we have x plus 3 to the 3/2 power, and we're going to raise both sides to the second power. The reason we're doing this is because this is going to get rid of the square root, and it's also going to get rid of this denominator of 2. So x squared squared gives us x to the 4th. The square root of x plus 3 times itself is just x plus 3. And on the right side, we're going to have x plus 3 to the 3rd power because we're multiplying 3 over 2 times 2. And when you do 3 over 2 times 2, that's just going to give you 3 at the end. So now we're going to move everything to one side. We're going to subtract x plus 3 to the 3rd power on both sides. And we're going to have the right side canceling out, leaving us with 0. And now everything is on the left. So we have x to the 4th times x plus 3 minus, we have x plus 3 to the third power, and all of this is equal to 0. So the next thing I want to do is factor out the x plus 3. And we're going to be left with, we have x to the fourth minus, this will reduce the x plus 3 to the third down to a power of 2. And then this is all equal to 0. And now from this step, what we're going to do is we're going to use a difference of two squares. So that's the idea we're going to use here. A squared minus b squared is equal to a plus b times a minus b. And in this situation here, I would say that a squared is equal to x to the fourth. So a would be equal to x squared. And then b, we would have b squared as x plus 3 squared. So b would just be equal to x plus 3. So now we could factor. We have x plus 3 times, and we have a plus b going in the first parentheses here when we factor this. So we're going to have x squared plus x plus 3. Okay, so we're just, once again, applying the difference of two squares formula to this expression here. So we have a plus b giving us x squared plus x plus 3. And then for the next part, we just have to be careful. A minus b, we're doing x squared minus x plus 3 entirely. Okay, so we have to use the distributive property here. We have to send the minus through like this just to make sure that we get the correct result. And all of this is going to be set equal to 0. So now we have x plus 3 times, and then we're going to say here x squared plus x plus 3. And then we have in our last parentheses here, x squared minus x minus 3, because once again, the negative is going to distribute through. So from here, we have to know the quadratic formula to find the roots of the second two factors. And we have negative b plus or minus the square root of b squared minus 4ac all over 2a. For the first factor, we could just set this equal to 0. We could just say, and I'll just write it over here, we could just say x plus 3 is equal to 0, and this is true when x is equal to negative 3. So far we have one potential solution. And then we have x squared plus x plus 3. So we have x squared plus x plus 3 is equal to 0. And for this one, we could use the quadratic formula. We have an a value of 1, we have a b value of 1, and we have a c value of 3. So we're going to say x equals negative b, so we have negative 1, plus or minus the square root of, we have b squared minus 4 times a times the c term, all over 2 times a. And if we work this out, we have x equals negative 1, plus or minus the square root of, we're going to have 1 minus 12 is negative 11, and this is all over 2. So these we are going to reject because the solutions here are imaginary. And the question said to find the real roots. So we're only concerned with real numbers here. So now we set the last factor equal to 0. We have x squared minus x minus 3 equals 0. And we'll use the quadratic formula again. This time we have a b value of negative 1. So when we do negative b, we have negative 1 is positive 1. And then we have plus or minus the square root of negative 1 squared minus 4 times the a term here is 1 times the c term is negative 3. And this is all over 2 times a. And from here we have x equals 1 plus or minus. And this time around we're going to have 1 plus 12 because we have negative 4 times negative 3 is positive 12. Negative 1 squared is 1, so 1 plus 12 is 13. So we have square root of 13 over 2. So here are the solutions. But now let's check our solutions to see if anything needs to be rejected. So we have negative 3 is one of our solutions. And I'm going to press store and then alpha math to store this as the letter A. And then one of our other solutions or potential solutions, I'm going to press alpha y equals enter to pull up a blank fraction. And we have 1 plus the square root of 13. And this is all over 2. And I'm going to store this one as the letter B. So I have alpha apps. I'm storing this as the letter B. That way, anytime I type in B, it's going to give me that decimal. And then the final solution here, we have 1 minus root 13 over 2. Okay, so we want to verify this one as well. So I'm going to store this one as the letter C. So now we go back to the original equation. And now I'll just replace the x's on the left side and right side with A. So notice left side and right side, we get 0 for both, so A checks out. And now we'll check for B. So notice we get a match for B, so that second solution is good. And now we'll check for the last solution for our value that we saved in the letter C. So all three solutions check out. Question 3, we're going to solve this equation for all real values x. We have the square root of 11 minus x squared minus, and then we have 2 over the square root of 11 minus x squared. And this is all equal to 1. So we're going to solve this equation, and then we're going to check our answers back to the original equation just to see if we have to throw anything out. So I'm going to call this first term square root of 11 minus x squared over 1. That way we could find common denominators. So we're going to multiply this first fraction here by square root of 11 minus x squared over square root of 11 minus x squared. And that's going to give us matching denominators with the fraction on the right here. So now we multiply these two terms. Square root of 11 minus x squared times itself is just 11 minus x squared. And this is over square root of 11 minus x squared. And we have minus 2 over square root of 11 minus x squared. And this is all equal to 1. So now that we have common denominators, we can combine these fractions. We have 11 minus x squared and then minus 2 over 11 minus x squared under the square root is equal to 1. And now just combine like terms. 11 minus 2 is 9, so we have 9 minus x squared over, and then we have the square root of 11 minus x squared like this. And this is all equal to 1, and I'm going to call this 1 over 1, so that now we could cross multiply. So we have 9 minus x squared times 1 is 9 minus x squared. And then we have square root of 11 minus x squared times 1 is square root of 11 minus x squared. And from this step, what we want to do is get rid of the square root. So we are going to square both sides. So on the left side, we could think of this as 9 minus x squared times itself. And on the right side, the square root just goes away and cancels out with the square. We have 11 minus x squared. So now we can expand. We have 9 times 9 is 81. And then we have minus 9x squared. We have another minus 9x squared when we distribute the minus x squared. And then we have a plus x to the fourth. And this equals 11 minus x squared on the right side. So from here, what we could do is combine like terms, and we could move everything to the left side. So I'm going to rewrite the left side in standard form. We have x to the fourth, and then we have minus 18x squared plus 81 equals 11 minus x squared. So we're moving everything to the left side. We're going to go plus x squared, and we could also say minus 11. So now on the left side, we have x to the fourth, and then we have minus 17x squared because we're doing negative 18 plus the invisible 1 in front of the x squared. And then we have 81 minus 11 is 70, and this is all equal to 0. Now from here, if you could handle factoring this fourth degree polynomial without substituting, then great. Otherwise, you might want to make the substitution u is equal to x squared, and then you can rewrite this equation over here as u squared minus 17u plus 70 is equal to 0. So now we're looking for two numbers that have a sum of negative 17 and a product of 70. And that would give us, we would have u minus 10 times u minus 7. And this is all equal to 0. So from here, we could substitute back for u. We would have u is equal to x squared. So we have x squared minus 10 times x squared minus 7 is equal to 0. So now we'll continue the work over here. We set x squared minus 10 equal to 0. And this we could solve. We have x squared equals 10 after we do plus 10 on both sides. We take the square root, but just make sure that you say x equals plus or minus the square root of 10, because the square root of x squared is equal to absolute value x. So that's why we're writing the plus or minus here. And then for the second factor, we would have x squared minus 7 is equal to 0. And this would give us x squared equals 7, which gives us x equals plus or minus the square root of 7. And this happens after we take the square root of both sides. So now let's check these x values. So let's say I plug in x equals square root 10 first. If I plug this one in, we're going to have the square root of 11 minus, and I'm doing square root 10 squared, which is 10. And we have minus 2 over, we have 11 minus square root 10 squared is still 10, equals 1. So from here, this gives us the square root of 1 minus 2 over the square root of 1 is equal to 1. But this is a false statement. This would give us 1 minus 2 equals 1, which is simply not true. Okay, so this would also be the same result if we plugged in plus or minus square root 10, because if I did negative square root 10 squared, that's going to give us positive 10 as well. So this will reject both of these solutions here. Okay, we are going to reject both of those. So now let's plug in x equals plus or minus square root 7. And I could plug them both in basically both at once because x is being squared both times that it shows up in the expression on the left. So this would give us, we would have the square root of 11 minus, and if I do plus or minus radical 7 squared, that's just going to give us 7. And we have minus 2 over square root of 11 minus 7 equals 1. And let's see what we get. We get 11 minus 7 under the square root, so we get square root of 4, and then minus 2 over square root 4 is equal to 1. So now we have the square root of 4 is equal to 2, and we have 2 minus 2 over square root 4 is 2 equals 1, and this gives us 2 minus 1 equals 1, which is true. So these are our two solutions. Question 4, we have this equation here, and we could start by squaring both sides. So we have square root of x plus c plus square root of x minus c, and this we're going to square. And this is equal to the square root of 2 times the square root of x plus 6, and this is also being squared. And now on the left side, we have to expand this. We're going to have the square root of x plus c plus the square root of x minus c times itself. So we're just going to multiply this out on the left side. And on the right side, this will just simplify nicely because it's a monomial being squared. The square root of 2 squared is 2, and the square root of x plus 6 squared is x plus 6. On the right side, we expand. We have square root x plus c times itself is x plus c. And then we have next, we're multiplying these two. So we have plus the square root of, and we've got x plus c times x minus c. So we might recognize this once again. We have a plus b times a minus b equals a squared minus b squared. So I could write the product under here, x plus c times x minus c, as x squared minus c squared. And then we have plus, and we're going to distribute this now, and that's going to give us the exact same thing. We have under the radical, x minus c times x plus c gives us x squared minus c squared. And then finally at the end, when we distribute radical x minus c times itself is just x minus c, and this equals 2 times x plus 6. So now we combine like terms, and we have c minus c canceling out. We have x plus x is 2x, and then we have plus 2 times the square root of x squared minus c squared. And this is equal to, on the right side, we have 2x plus 12 after we distribute. So we're distributing here. So notice we have matching 2x's on both sides, so we could just subtract 2x on both sides, and we have 2 times the square root of x squared minus c squared is equal to 12. So from here, first I would divide both sides by 2, and this would give us, we have the square root of x squared minus c squared is equal to 6. And from here, I would square both sides. So now in the next line, we have x squared minus c squared is equal to 36. But c is being treated as a positive constant. So from here, we could say x squared is equal to c squared plus 36. So solving for x, we take the square root of both sides, and we have x equals plus or minus the square root of c squared plus 36. So now let's check our two x values. We have x equals the square root of, we have c squared plus 36 under the radical, and then we have x equals minus square root of c squared plus 36. Since c is a positive constant, that means c squared plus 36 is always positive, so the square root of that would be positive. And then over here, we have a minus in front, so that would make the entire thing negative, because we have a square root of a positive is positive, but then times, think of that as -1, would give us a negative. So now if we focus on this piece over here, if we were to plug into this, we would have the square root of x minus c, in this case, we would say is imaginary. Because if we are replacing the x with something negative, and then we do minus c, which is a positive constant, we have a negative minus a positive number here is going to be negative. So we're taking the square root of a negative, which would give us something imaginary. So that means we are going to reject this root over here. But if we look at the other one over here, if we plugged in x equals c squared plus 36 under the square root, this would give us something positive all the way across for all of these radicals. So this tells us that our only solution is x equals the square root of c squared plus 36. If you're unsure that this part is always going to work out to something positive for this root, what you should note here is that the square root of c squared plus 36, if c is a positive constant, is always going to be greater than c. The reason being, the square root of c squared is equal to c. So if I add 36 under here, I'm definitely going to get something greater than c. So if I subtract something greater than c by c, I'm going to get a positive under this one. So that's how I know this one will definitely check out. Question 5, our last question. We're going to solve for all real values of x, and we're going to assume a and b are positive constants. So first, I want to rewrite this in rational exponent form. So I have x to the 1/2 because I have the square root. With the square root, the invisible root is 2. And if there's no power in front of the x, the invisible power is 1. And then we have minus a times x to the power 1/3. And then we have plus b times x to the power 1/6. And we have minus ab is equal to 0. And now from this part, this might be a little bit tricky to see, but we can make a substitution here. If I say something like u is equal to x to the 1/6, then if I square both sides, I would have u squared is equal to x to the 1/6 squared, and this would give us x to the 2/6, which would give us x to the 1/3. And notice that it would replace this term over here. If I do u to the 3rd power, that would give us x to the 1/6 now to the power 3, and that would give us x to the power 3/6 after we multiply these exponents, which would give us x to the 1/2, which we could then use to replace this term over here. So now we could substitute. We could rewrite this equation as u to the 3rd power minus a times u to the 2nd power, because u to the 2nd power is x to the 3rd, and then we have plus b times x to the 1/6 is equal to u, and we have minus ab equals 0. So now from this step, we're going to use factoring by grouping. We're going to take out a greatest common factor of u squared, and we're left with u minus a. And then we have plus, and here we'll take out a greatest common factor of b, and we're left with u minus a, and all of this is equal to 0. So now we can factor out u minus a, and we're left with u squared plus b is equal to 0. And now at this step, what we could do is we could plug back in for x. So we have u is equal to x to the 1/6, and then we have minus a, and then u squared is equal to x to the 1/3, and then we have plus b, and all of this is equal to 0. So now we could set each factor equal to 0. We have x to the 1/6 minus a is equal to 0, and we have x to the 1/3 plus b is equal to 0. The first equation, we could add a to both sides, and we have x to the 1/6 is equal to a, and to get rid of the power 1/6, we could raise both sides to the reciprocal power. So I'm going to raise both sides to the 6/1, but I'll just call it 6. And then we're going to raise the right side to the power 6 as well. So this gives us x equals a to the 6th power. And now we're going to solve this equation. So we have x to the 1/3 equals negative b. We're just going to do minus b on both sides. And here we're going to raise both sides to the power 3. So I'm raising both sides to the power 3. And this gives us x equals, if we do, let's say over here, negative b times negative b times negative b, this would give us negative b to the 3rd power because we have an odd amount of negatives. So now let's check. We have the square root of a to the 6th power minus a times the cube root of a to the 6th power, and then we have plus b times the 6th root of a to the 6th power minus ab is equal to 0. So for this one here, the square root of a to the 6th power, just think of this as we have a root of 2. We could write this as a to the 6/2, and then we have minus a times a to the 6/3. We're just using power over root. And then we have plus b times a to the 6/6, and then minus ab equals 0. So here we have a to the 3rd minus a times a squared, and then we have plus b times a to the 1st, and then we have minus ab equals 0. And if we simplify, we have a to the 3rd minus a to the 3rd plus, I could rewrite this as ab, and then minus ab equals 0. And notice what we have 0 equals 0. So this first solution here checks out. But then if you look at the second solution, right away when we plug in square root of negative b to the 3rd, if b is a positive constant, then this would be imaginary. So this is imaginary because we have the square root of a negative, okay? And this is imaginary because, I'll just say over here, minus b to the 3rd is going to be less than 0 because we were told in the beginning that b is a positive constant. So this tells us we would reject the second solution over here, and this would be our only solution.